right, well, we're here. Thank you all for showing up. So it's nice to see everyone's face. So right now I'm in gallery view. If everyone can also join me in gallery view, we can all see each other. So welcome to Y Exchange. A lot of you already know the spiel I'm gonna give, so excuse me for that, but welcome new folks also. We're really excited for this one. We're featuring Antarctic explorer and creative director Ariel Waldman alongside Aerosol scientist, biophysicist, and inventor David Edwards. And it's an immense honor to have you both here today. So I just want to go through a few things before we begin. Y Exchange is co-produced by Kinetic Arts, ODC Theater, and the Jurassic Residence Artist Program. Each presenter today will have 25 minutes to show their work and share their projects, followed by a 15-minute Q&A with everyone here. So when you are watching the presentations, please feel free to ask your questions in the chat. And as soon as the presentation is over, I will handpick those, go in order of those questions and call on you guys to ask your questions during the Q&A. So as you know, I will be the Zoom host here, labeled there on your screen. I will be the moderator in the chat. I will be helping out with any technical challenges, so feel free to message me directly. You can use closed captioning on the bottom here with the CC on the bottom of your Zoom screen if you need that. Also, as soon as the presenters speak, you'll see speaker view, but once we get into the Q&A, we'll have everyone in gallery view so we can, again, engage in conversation and see each other's faces. And I think, those are the logistics. This is a free public event. We record it. So if you do not want to have your face in the recording, please turn off your camera or let me know. You can direct message me. And that will be it. And the first presenter today will be Ariel, followed by David. And I'll do a little introduction, a little background to Ariel's work. And John will give me a little bit more context, and we'll go from there. So give me just a second. Here we are. So Ariel Waldman creates imaginative projects that explore the world below our feet and beyond our atmosphere. An art school graduate who pivoted to science, she has been recognized by the Obama White House as a champion of change in citizen science. Ariel is also the global director of Science Hack Day, which has grown to span 30 countries and serves as a prime inspiration for NASA's International Space Apps Challenge. As an Antarctic explorer, microscopic wildlife filmmaker, producer, and host, she has filmed a series of YouTube videos documenting her science adventures, including an expedition to film life under the ice in Antarctica. And so I'll let her take it from here. Ariel, thank you for joining us.
Wait, I gotta pile on and say Ariel's really cool.
Good one. Thanks, John. All right, I'll let Ariel take it from here.
Thank you so much, Alex. Let me just get started here. All right, so yeah, hi, good evening, everyone. Thank you so much for coming. I'm really excited. I really am excited about this event series in general because it's all about the combination of art and science, which is really, part of my story and a lot of why I'm here in front of you today. So I always love starting my talks with one of my absolutely favorite images from space. It's this image here. And this is a image taken by one of my favorite spacecrafts, the Voyager 1 spacecraft. And if you can see that tiny little pale speck of a pixel there, that's Earth as seen from about 4 billion miles away. So I always say, that's where you can find me if you need me. And, the reason why I love images like this from Voyager 1 and other spacecraft so much is because it really showcases how space exploration and science change our view of ourselves and our place in the universe. And I think a lot of my work in a different way tries to change how we view science and space exploration. My background is not from a traditional science background. I went to art school and I got my degree in graphic design, and I, absolutely loved it. My dream job growing up was to be an executive creative director. I thought that was the coolest thing because I thought that meant you get to essentially apply your art and design skills towards the entire world. And I just really was in love with it. And I loved going to art school and how it allowed me to really, I guess, actually make things and build things. And I apologize if you're getting any of the sounds in the background while this is going on. But so I really loved art school, and that's kind of the course that I was set on and totally happy with. But a few years ago, I was watching a documentary called When We Left Earth, which was this fantastic documentary about NASA during the early days and how they were trying to figure out how to send humans into space for the very first time. And I saw this and I got instantly inspired by this documentary, specifically because as they were interviewing different guys, and they were all guys from mission control in the early 1960s, and they were saying, how they got involved in NASA, they were talking about how, they didn't know anything about spacecrafts or rocketry or orbits, that they were having to figure it out as they went along. And so I was watching this and I was kind of like, well, I don't know anything about space exploration and I would love to work at NASA. That sounds amazing. And so I decided on a whim to kind of send someone at NASA an email saying I was a huge fan of what they were doing. At that point, I was like a fan for all of like 2 weeks or something. But saying, if they ever needed someone like me, someone completely without a formal science education, but who was really passionate about just getting involved, that I was here. I never expected to hear back at all from that email because it was just a fangirl email, really. But serendipitously, I ended up actually getting a job at NASA from that email. And this is what it felt like. It's just like, oh my God, what is even happening? And it was unexpected and really delightful. And it completely changed my view of so many things, having this sort of shot in the dark thing happen to me. It really changed my view of NASA from being a bunch of rocket scientists to being a bunch of space hackers. They were people who were trying to figure out things as they went along. They weren't experts in everything. Not everything was known. A lot of it was unknown, and they had to, kind of work with other people and collaborate and figure things out. And so that was really great to see. The program that I got to work with at NASA was called CoLab, which sought to connect communities inside and outside of NASA to collaborate. And so they specifically actually wanted to work with someone who had no experience with NASA so that I could really help bridge the gap between these communities inside and outside of NASA. So, working with amateur astronomy communities, working with startups in Silicon Valley, a lot of different communities. And so I was brought in specifically so that I could help translate and be that liaison. And it was really fulfilling work and work that really changed the course of my life. It really changed me because it was around this concept that doing something changes how you see it. So actually doing science and doing space exploration really changes your relationship with it from something of observation to something of active participation and contribution. And so that's what it really did for me, is I realized that I had, value to add to science and space exploration in a way that I never realized before. And once I knew that, I kind of wanted to shout it from the rooftops to everyone else, that there's actually really valuable ways that people can contribute to science and space exploration, even if they come from an entirely different background, and that it doesn't necessarily have to be something where you have to drop everything and get a PhD in science in order to actually be really valuable to science. There's so many different ways of looking at the world and different disciplines and skill sets that are actually really, truly needed by science. And some people realize that and some people don't. And that's the tricky thing of navigating it. So one of the important things that I learned while I was at NASA was that I didn't need to be an astronaut in order to explore space. That was really key. And then even further, I ended up learning that I didn't even need to work at NASA to explore space. And so I left and I created spacehack.org back in 2008. So this was definitely ahead of its time, but it was a directory of ways in which anyone could participate in space exploration with or without a formal science background. So ways in which you can discover black holes or help build the next generation of Mars rovers, all sorts of different things that people can get involved in. And it was really in 2008, trying to showcase that there are all these pathways to get involved in space exploration and actively contribute to it that don't necessarily require you to get a PhD in some specific science discipline. So kind of after Space Hack, I was kind of on this role about multidisciplinary collaboration and getting people from different fields together to make really awesome stuff. And so one of the frustrations that I had while doing that type of work was realizing that there's a lot of open science stuff out there and available in the world, but people weren't really doing many interesting things with it. And so sort of born out of that frustration came Science Hack Day, which is a weekend event that gets designers, technologists, writers, scientists, all sorts of people together in the same physical space to see what they can rapidly prototype with science in 24 consecutive hours. So the mission of Science Hack Day is really just to get excited and make things with science. We don't issue challenges. It's very open-ended, and we kind of let people explore what they want to explore and prototype things to any fidelity that they want. So you don't have to have specific tech skills or any specific skills at all. It's really just about what excites you and how can you prototype it. For some people that's cardboard, for some people that's miming, for other people it is like a very technical software build or using LiDAR, all sorts of different things. And so some people make silly stuff, some people make serious stuff, but really it's about the serendipity that happens when you get people from different disciplines together and making things. And there's been so many amazing outcomes from this that I could spend the rest of my talk on this, but I'm going to keep going. This is Science Hack Day in San Francisco. We ran 10 annual events in San Francisco. The events had around 200, 250 people. This is a couple of different years from Science Hack Day San Francisco. It was really fun. It was really great. People have written and talked about all the different ways in which Science Hack Day has really made an impact, about making it unintimidating for people who don't come from science backgrounds, but equally for people with science backgrounds, that it's really fundamentally changed the way they work and the way that they realize that they can collaborate with people. So it's really fantastic. And you have scientists learning just as much as you have people from non-science disciplines learning. And it's just really fantastic. Science Hack Day has happened all over the world in 30 countries so far, including also Antarctica. And it's just been great to see it grow over the last decade. One of my favorite places I was able to visit was Science Hack Day in Madagascar. It was just a ton of fun. So as I said, I could spend the whole talk on that, but I also want to get to Antarctica because I know everyone's really excited to talk about Antarctica. So the thing that I like about Science Hack Day is that, having adults play with science to me is one of the most empowering forms of science engagement, and it really changes people's relationship. And it's going back to my experience of, working at NASA changed my relationship with science. So it wasn't just about, seeing cool stuff that got me excited, but actually giving me a chance to do something real in the real world. This is kind of a great photo from Science Hack Day that showcases that. And so a lot of times when I get asked about the work that I do, people have asked me about, is it, the drive to create that pushes you to explore, or the drive to explore that pushes you to create things? And, it's definitely a little bit of both, but it's really, for me, coming from an art background, it's really the desire to create things in the world that really drives me to explore and makes me really hungry to explore more, because I always want to create all these awesome projects and things out of it. So, related to that is Antarctica. And like I was saying, when I learned that I didn't need to be an astronaut to explore space, I was really kind of relieved, because I suffer so much from motion sickness. I get so sick. And so I'm not quite sure if going into space is my dream of dreams. I might not say no to it, but I know that I have my reservations just because I get so sick. But I thought about, well, what is my version of going to space? What is my extreme? What is my, pinnacle thing that I want to try and do in my life? And I realized that, for me, it was going to Antarctica, because so many places in Antarctica are like places in outer space, icy moons around, Jupiter and Saturn, or there's a lot of places that are like the surface of Mars. So I thought that was kind of close enough, like, getting to explore this kind of otherworldly place here on our planet, on our world, and I get to keep an atmosphere and I get to keep gravity. So I thought that's pretty great. I should go for that. I also wanted to go to Antarctica, though, to contribute and be part of science. I didn't want to go just as a tourist. I wanted to really be with all of the nerds in Antarctica doing amazing science and actually giving back in some way to this amazing, pristine continent. And so because I don't have a background in science, despite working at NASA, that didn't mean I was like a shoo-in for going to Antarctica. And I had to figure out, how do I go to Antarctica without a formal science background? And I learned that the National Science Foundation has a program called the Antarctic Artists and Writers Program. And so I looked into it and it looked pretty compelling to me. And I was trying to figure out what to do because, I'm, despite going to art school and getting a degree in design, I'm terrible at drawing, painting, all of it, like not great at it. I enjoy it, but I'm really awful. So I thought, well, what can I sort of add here that would be of value? And in talking with a lot of biologists that went to Antarctica, I learned that even though there's all this great science being done there, they very rarely take photos or videos of the creatures that they're studying. They do all this amazing science. They maybe take 1 or 2 photos. Those photos go into a science journal that then gets behind a paywall. And not many people actually get to see that Antarctica is actually full of life, that there are all these microbes and amazing tiny animals in Antarctica that no one gets to really see. Everyone thinks of penguins, or that there's like penguins and nothing else. But the reality is there's a lot. So I kind of set my sights on becoming a wildlife photographer or wildlife filmmaker at the microbial scale and started teaching myself microscopy. I joined the San Francisco Microscopical Society, which is a fantastic geeky group. Fun part of this whole journey is that now I'm the president of the San Francisco Microscopical Society, now years later. But they were a fantastic group for me to join years ago. And they're a great place for, artists and scientists to connect with one another and kind of explore the world, the tiny world, so to speak. So also in the San Francisco Bay Area is Merritt College in Oakland, which has a fantastic microscopy program. So if you're interested in actually being taught how to be a really great microscopist, no matter your discipline, Merritt College has this really great program that you can join. You don't have to be an existing student. They're based in Oakland and they're just fantastic. So I spent 5 years applying for this NSF Antarctic Artists and Writers Grant. I did not expect it would take me 5 years, but it took me 5 years of applying. And after 5 years, I finally got the go ahead to go to Antarctica. This was all my gear that I went to Antarctica with, which was like microscopes and lab gear, and the smaller cases my clothes. It was around, I think just short of 200 pounds of gear. And then I finally actually got to see what Antarctica looked like. So I flew down on a C-17 military aircraft that had no windows except for this very tiny hole that you can see here. And this was the very first time that I actually got to see Antarctica with my own eyes through this very tiny porthole on this military aircraft. And it was just really special and not exactly how you think of it, that you're going to be piled in like sardines into this huge aircraft and then barely be able to see out. But this was literally the first time I actually got to see it. So the work that I was doing in Antarctica was all about filming all of these microscopic creatures that live under the ice in all these different locations, and to really showcase that Antarctica is full of life. So some of the locations I went to were locations like this. This is the sea ice around McMurdo Station in Antarctica. And you can see there's this little fish hut. And what's really exciting is inside of that fish hut is this. There's a hole that they carved through like the 9 feet thick ice And they keep that hole open. And this is actually where Antarctic divers go down underneath the 9 feet thick ice and explore the sea floor. And when I heard about this, I thought, like, who would want to do this? You know, the temperature of the water is -2 degrees Celsius. So it's below freezing because it's salt water. And so it doesn't have the same freezing temperature, but so it's just absolutely frigid. One of the things that was cool is that they actually also embed a metal pipe into the 9 feet thick ice that you can crawl down into and experience what it's like underneath the sea ice without having to get a diving suit on. So I'll just start this video so you can see. It's kind of like, you know, Mario, you get to like go down into this little hole, you climb all the way down, and this is what you see at the bottom. And what you're looking at is the illuminated sea ice at the top, and all those little specks are fish that I'm watching. And it was just magical. This is me, you know, inside of that little tube. And it just actually showcased why anyone would want to be an Antarctic diver, because there's actually just tons of interesting life underneath. This is what that tube looks like from the outside. So you're just like in this little suspended thing between the sea ice and the sea floor, and you get to, you know, get selfies with divers and all sorts of things like that. So some of the creatures that I filmed that were from underneath the sea ice and in the sea floor were things like this. This is a diatom. Diatoms are little glass shells containing microalgae. So literally glass shells. So they're made of silica, and they are just these little geometrically shaped things all over the world. And they're just amazing because when you see them for the first time, I mean, they look like they're designed by a human or something. They're just really amazing little critters, so to speak. There were also like shrimp-like things that I saw. And then this one, which is a seed shrimp, also known as an ostracod. And I just love it. It has these little frilly legs and everything. And this is, you know, started to get at like what I love so much about doing work like this is that there's all of these creatures and all this life in Antarctica and even in other places in the world that we're just not really familiar with because no one's really documenting them and filming them at length. At least not a whole lot of people are. So one of the other locations I got to go to was Blood Falls, which is this really amazing phenomenon in Antarctica that you can see. It's got all of this red, you know, colored stuff coming out of this glacier. And what's fascinating about it is that when it was first discovered a long time ago, people thought it was maybe algae, and then it was discovered, oh no, it's iron oxide. And then for a long time, people thought it was completely dead, that there was no life in it whatsoever. But it turns out that even in this iron oxide that has been in a subglacial lake for millions of years, it actually has bacteria in it. And you can actually see that it's actually like everything else, full of life. This is not as charismatic as the other creatures, but this is the bacteria from Blood Falls that I was able to see, and they all each have their own little dance moves, and I don't know, they're still delightful in their own way to watch. So this is me in Antarctica with my microscopes inside a tent, just having the time of my life looking at all these little bacteria and creatures. Some of the microscopes I used out in the field were really short ones, small ones like this. This is a handheld microscope that you can use in the field, and I had an iPhone attachment to it. It came in, excuse the pun, but it came in very handy. And the other fun thing that I learned while I was doing this work that sort of goes back to my work in Science Hack Day is that, you know, there's all of these researchers and scientists, and you would think they use microscopes all the time because that's the stereotype, but they don't. And so I brought a microscope into one of the field camps, and everyone was just instantly fascinated about like looking at their fingers and cork and all sorts of things, looking at cookies under the microscope, all different types of things. It just, this was like filmed at like 2 or 3 in the morning. Antarctica in the summer is like constant sun. So we were just having all these late night sessions looking at the microscope and just having a great time. And this is the thing that is really great about microscopy is it's sometimes seen as an antiquated sort of thing. And so I am trying to revitalize that. And I think you can really wow people from, both inside science and outside of science with microscopes. One of the other locations that I was able to visit was here in front of Canada Glacier. The tent, I think on the right is my tent. And it's this amazing space in the dry valleys in the Antarctica. And a lot of these spaces were in the dry valleys, which is the largest swath of Antarctica that is not covered in snow and ice due to the mountains that surround it. So 98% of Antarctica is covered in snow and ice, but this is one of the places where you actually get to see the actual continent itself. And so I was able to actually, this was precarious for me, but I climbed up this glacier. I'm not like a super, athletic person at all. So this was definitely a big adventure for me. But I climbed up this glacier, and the reason why I did is because we wanted to drill down into the glacier. And why we wanted to drill into the glacier is because embedded inside the glacier itself are tardigrades and rotifers and nematodes, all sorts of critters. Essentially what happens is as little pieces of dirt get blown onto the glacier, they melt down into the glacier, and then you get these dirt pucks inside of the glacier that are full ecosystems of all these little microbes living embedded inside ice. So you can see here, we're not actually looking for that ice core, but we're looking for that, which is a dirt puck that is just full of microbes. And so all over this glacier are these little dirt pucks, 2-3 feet down into the glacier. And each of those is its own little closed, encapsulated ecosystem of predators, prey, everything in them. And it's really fascinating. So this is some of the footage of the creatures from those little pucks, which are known as cryoconite holes. And so it's like you get tardigrades and all sorts of stuff. They're really cute. I always say they're like little gummy bears with worms. There's one here that you can see even better. So yeah, little gummy bear with claws, sorry. So I was thinking like gummy worms and gummy bears with claws are what they are. And they're just adorable and cute, and they're just living their best life embedded inside glaciers, which is why they're so amazing. And so this is also a ciliate that was inside of one of them. It's, kind of, you get to see it poop. It does all these amazing things with its stomach that you get to see. This is also a rotifer. Rotifers have these like heads that then open up into these sort of like Roomba-like cilia, which is like little hairs. So now you can see it with the little hairs. The thing that's beating inside of it is not its heart, it's actually its esophagus. So tardigrades and rotifers are actually tiny animals. They're not bugs, they're not bacteria, they are actually animals. They're the tiniest animals on Earth. And they live in Antarctica and many other places. So a lot of my work really is around breaking single narratives, that there's only one way to do something or one way to accomplish something, or that you have to meet some sort of idea of a start and end point for a certain path. So in my own work and the work that I do, collaborating with others, I try to break single narratives and try and showcase that there's different ways to do things. It doesn't always mean that they're easy. It doesn't always mean that I'm successful in navigating how to do all the things that I want to do. But it's a lot of at the core of what sort of drives me is to really open up many different ways and narratives in which people can do interesting work. And so the output of my work in Antarctica was creating lifeundertheice.org, which is a website where it takes all of the videos of all these creatures that I filmed in Antarctica, and you can actually navigate around and zoom in and out of them as if you're looking in a big petri dish underneath the microscope in Antarctica. So if you really want to get a sense of all the different things that life that exists in Antarctica, and get a sense of what it's like to actually see them and navigate around and go looking for them, lifeundertheice.org is a really fantastic sort of interactive website for that, so that you can actually get that feeling of what it's like to put something under the microscope and see a bunch of different stuff. So definitely check out lifeundertheice.org. it's just a really great resource that people enjoy. I think, some of the stuff that I've seen that people like about it is that, you get to see things that you've never seen. It really, for some people is mesmerizing, as they say. For some people it's an amazing scientific resource. They've used it in classrooms. I enjoy that other people have talked about it. It's like watching a live camera in the zoo. And this is really accomplishing what I'm trying to do with that type of work, is trying to make people, actually have the experience of what life is like on our planet, because I think it's really sad that we're surrounded by so much life and we only get to see a small subset of it. So I want to change that. And sort of related to that, after I came back from Antarctica, I created a how-to video that's on Adam Savage's Tested, that's all about like how you can find tardigrades in your backyard. So tardigrades are very, famous for being these extreme creatures that can survive the vacuum of space and survive in Antarctica. But the reality is, if you see a sidewalk crack with moss in it, or a planter in your garden with moss in it, there's a really good chance there's tardigrades in it. So I did a how-to video for how you can find your own tardigrades in your own backyard, and showed what tardigrades look like with different types of microscopes. You don't need an expensive microscope or anything fancy. A kid's microscope will work just great. So the thing that was fun about that is a lot of people, from that video bought their first microscopes and actually saw their first tardigrades with their own eyes. And again, I think that's a really empowering thing, to be able to actually physically do something in real life. That's really exciting like that. So that video and videos from my Antarctic expedition and all of that stuff are all on my YouTube channel, which is just youtube.com/Ariel Waldman. You can check it all out at your leisure. So with that, I will hand it over and say thank you very much.
Thank you. I'm going to bring everyone back to the Q&A. Thank you, Ariel. Everyone come back to the gallery view. Amazing. That was so much packed in there. So I didn't see anything in the chat, so I want to open up the floor for all of you to ask your questions. You can just unmute yourselves. If anyone has anything to start, don't be shy.
Ariel, what are you working on these days?
Right now, I am working on a book about the science of science fiction. So I recently got a book deal based off of a show that I had on Adam Savage's Tested that was called Offworld. And it was all about space exploration and pop culture. And we talked about a lot of films and TVs, and brought on researchers to talk about like, okay, so we see black holes depicted this way in, film, like, let's actually like talk about the science behind it, and, where it's an exciting place for science fiction and where it's exciting for science. So lots of different topics. And so now I'm turning sort of that show and, inspired by that show, I'm turning a lot of that into a book. And I'm really excited about that. So that will come out in winter of 2023. So it's a ways off still, but it's taking up a lot of my time right now. And then my other big project is going back to Antarctica, hopefully in about a year from now, to do some similar work that I was doing, but also be embedded in a research team this time, rather than being a team of one like I was on this last one.
Yeah, Ariel, beautiful, beautiful work. It's a very touching, very moving. I have to say that there's not enough appreciation of science in the society, and I love the work that you being like a transcribe science in the nature, the life into something so beautiful, so connecting to people, and this is amazing. Just a note, I've just a question for you is that from what I want to hear your thought about how can we make science more appreciable by the general audience, the general public.
Yeah, I mean, that's a big question for sure. But, I think there are a few things that can scratch at it from different angles. You know, one of the things that I've certainly seen is that it's not usually okay to assume that everyone is interested in a certain kind of science. So I see this a lot from the NASA side and space exploration side. People a lot of times make assertions that like everyone is really excited about space and everyone has spent their childhood, you know, looking to the stars and thinking about space. But that's not the reality, you know, for everyone. That's certainly true for a lot of people. But different sciences excite different people. And so that was one of the things that we really incorporated into Science Hack Day, was not doing like a space themed one or a biology themed one, because everyone has something different that they're interested in, and sort of honoring that and respecting that, and not trying to like push people into one area of science or another, I think is important. Another thing that I've seen is, you know, from my own sort of navigation of these spaces, is that I think the science industry and academia sometimes unknowingly put themselves at the top of the heap of like, you know, this is what you should strive to be. And I find that can be really off-putting. So for instance, a lot of times when there's outreach to young girls, there's this idea that, you know, yeah, you want to make science accessible and fun, and you want to make science something that young girls have every opportunity to get into. But if some of those girls then say, well, no, I really am interested in fashion, a lot of times the science world will sort of react to that as like, oh, they chose the lesser path, they chose the less intellectual path. And it's so off-putting. It's seen as this, like, if you don't go into science in college, then you're kind of lost to science, you know, forever. There's no returning unless you get that PhD, you know, later in life. And I think it's really to the detriment of science. And I think at its core, it can actually be really reckless, because then it means, you know, we're losing out on so many amazing collaborations and ways of engaging people, because we see it as, oh, we lost them. We didn't win that one. That one went to, you know, to art school or something. And so since my own journey sort of began after college, getting into science and everything, I think I've seen that, you know, there's a lack of self-awareness about sort of those messaging, that type of messaging, and how it can sort of get interpreted as, well, if I didn't get into it when I was targeted in middle school and high school, then I guess they're not interested in me anymore. And it's really sad. And I think that really needs to change. Those two examples are by no means going to fix everything in your question. But, you know, those are two things that I've seen that I think a lot of good could come from changing those.
Well said.
I can answer that question to you. You make a cute website like she did. Like, I'm dying to go to that website and learn about the tardigrades. Is that how you say it?
Mm-hmm.
That's how I get people to be interested in science. It's so cute. I just want to go there and learn everything about them.
Yeah, definitely do.
Yeah. There was someone trying to talk. Alex.
Yeah.
B.
I have a question about that first image of the Earth in space and all of that, and I'm assuming that there was a lot of noise in that picture, but Earth was in a band, I think it was reddish, and below it there was a band of greenish. Does anybody know what that's all about, or was that just noise?
I'm fairly sure that's sun glare. So Voyager 1, as it was going out, it had to turn back towards Earth and towards the sun in order to see it. So the bands of color you see are sun glare as seen from a 1970s, you know, spacecraft.
Mm-hmm. Thank you. It was a great talk, really exciting. Thank you.
Yeah, I want to say that your experience there was super inspirational. I love the way you approached the science and bringing the science home. So I was a National Science Foundation Antarctic Artists and Writers Program grantee in 2006 and went to Palmer Station.
That's fantastic.
And took molds off the glacier ice and stone for my own work. So I'm I feel like we're fellow Antarcticans.
Definitely.
How many times have you gone down there?
So I've only gone down in 2018, and then I was supposed to go down these last 2 years, but the pandemic had a different, I think. So a year from now, it's looking good that I'll finally be able to go back.
Super.
Let's hope the Earth doesn't get so warm that Antarctic is the only place we can
No,
live.
that's never going to happen. There's accumulating ice at the South Pole, and so it's only losing it around the edges.
And I wanted to pass it on to Russ, who also had a question here. Do you want to unmute yourself and ask? There you are.
Well, I'm in a restaurant, so I don't know if this will work very well, but I had a question about the microscope. With a website which I posted, Foldscope. It's a very inexpensive microscope that people can put together, fold it together. It's a piece of paper, basically. It's a kit. And I've seen tardigrades and other things. It's a very interesting way of doing it. I'm sorry if you can't hear me.
Sorry.
No, go ahead. Yeah, so Foldscope, yeah, it's a really fantastic paper microscope that was designed by a guy and his team out of Stanford, I believe. And yeah, it's really fantastic. So yeah, if you want to go like the super cheap route, you can get a Foldscope. The optics on it are, you know, a little bit more fiddly to deal with, but you can definitely see some stuff.
And tardigrades, just one more point. My understanding is tardigrades are in everybody's eyelashes. You can sort of scrape your eyelashes. They're actually little animals inside your eyelash, between your skin and your eyelash. They're helping to clean things out. So
yeah, that might be more like mites, but not tardigrades. But yes, yeah, there's all sorts of weird creatures.
Anyway, that's what I've read. So anyway, thank you. Bye.
Thank you for sharing the link to that. That's awesome. Check this out. Does anyone else have any last question while we close up the Q&A here? Time for one more.
I just one comment, Ariel. I love your Science Hack Day, and over here with the Kinetech Arts, we also host. Actually, John hosts like a Dance Your PhD, really fun events, and we host Dance Hack. Annual event of like, just imagine you put like engineer scientists together with the dancer and choreographer. What could happen? Many things doesn't work, but amazing thing always happens. So at some point, love to exchange experience with you to see what can we make this kind of event work, or people coming from very diverse discipline background. And they normally cannot talk to each other because they both use English, but use the words in a very different way.
Yeah.
But how can like this like synergy happen?
Yeah, and that brings up a great point, because you know I don't have the link for it offhand, but I wrote a post that maybe you can Google for called like 6 fears that keep event organizers up at night. So maybe if you do 6 fears in Ariel Waldman, you'll find it. But it was, yeah, detailing all of that of just like, you know, after a decade plus of event organizing, like what have I learned about like getting people to collaborate, and where I see common pitfalls in other events, and ways in which sort of you can just let humans be their awesome creative selves and help just facilitate that. So yeah, it's an art for sure.
Yeah.
Oops, sorry. Thank you, Ariel. This is the most fun presentation for me. As
I have a question. Can I still ask?
Okay. Yeah, go ahead.
Yeah. Well, my question might be simple or whatever. And it's like you were in a company of scientists and so forth. And how did you overcome the fear, or have the confidence to just be you? What does it take?
That's a really fantastic question, and something that, you know, I think like, you know, being self-employed, going to Antarctica, doing the things that I do, a lot of people assume like, oh, you must be real courageous because I can't do that. I was like, no, you're terrified the whole time. Like, you just do it anyway. But specifically, it's a great question about Antarctica because I did so much extensive work in the science world before going to Antarctica. I was on, National Academies committees. I was advising NASA. I was doing more science work than artwork for a long time. And I was really, self-conscious about going down on this artists and writers program because in my experience, going to science conferences, if people learn that I don't have a traditional PhD background, they either instantly get, uninterested, or they think I don't know anything, you name it, sort of typical responses. And so I was really worried that that was going to happen in Antarctica. And I was really blown away and delighted that the way the National Science Foundation has set up this artists and writers program, which has lasted for decades, they really have done a great job as organizers and curators to really make the program something that is exciting to everyone and people aspire to. So I was nervous that researchers and scientists were going to kind of write me off, but my experience was entirely different from anything that I've kind of experienced in the US. People were genuinely excited to hear about what my project was about, and they asked lots of questions. They didn't make assumptions that I didn't know what I was talking about. And I think a lot of that was in how the program was presented to the community there. And I don't know all the details of all the work that they do, but pretty much you're like the awesome rock star when you go to Antarctica as an artist, because everyone's like having to work really hard. It's 6-day work weeks there, and everyone would love to like just be able to take the experience that they have there and make artwork out of it. Like the researchers want to do that, the plumbers want to do that. And so you sort of have this unique situation where everyone sort of recognizes like, oh, how awesome would it be to be here and not be, doing what I have to do on the, whatever work they're doing 6 days a week, but I could actually take time to work on art. So I think the lesson there is really that, there can be inclusive communities. And I think it does take years of work of really having from the top down embrace of art. And I can see it in some other institutions too. I've seen Fermilab, the particle accelerator outside of Chicago, has had an art program since sort of their founding. And so I think top-down embrace that lasts over years and isn't just a one-off can really make a difference and really make it easier for people like me who are, honestly self-conscious about coming into a group of researchers and not having a traditional background.
Can I make a comment? And that is that my experience was in a much smaller community at Palmer Station, that everybody was looking at nature from a different point of view. And so a lot of the science was about measuring things that people could see and basically see. But the artist has the opportunity to measure and discuss things which are unseen. And so it expanded the knowledge base, the repertoire of the way we understand that land, to have the artists there. And I think that was one of the most exciting conversations I was able to have with the scientists.
Yeah, amazing. I know Jurassic hosts annual scientific delirium artist residency program for the artists and scientists together. The share the different perspective come together. It creates such a rich excitement.
Actually, Tara Fuller is here. She's the program director of Jurassic Resident Artist Program. If you don't know Jurassic, it's located on the mountains of Santa Cruz, and it's an incredible place. Every artist wants to go there, and when they are there, they don't want to leave. I see there are a few alumni here, and Tara, did the program change name? Is it called Leonard?
Yeah, no,
the-
it's called Leonardo at Gerasi with the @ sign. A little more simple, but it's the same at this point. Yeah, it's the same though. I mean,
I
with
miss
changes for
delirium.
COVID. What way?
Oh, I miss delirium.
Well, not a lot of people miss that. So you're one of the only. Yeah.
And I just want to say also that Dai is the artistic director of Kinetech Arts. I didn't get to introduce you in the very beginning, but you know, and Wei is also also directing and helping out. And there's a lot of people here. It's a team effort to make Kinetech Arts do this monthly event and open labs and anything that inspires us on the intersection of art and science and technology. So it's such an honor to have this space and to be here with everyone here. So I just want to say thank you for joining this conversation. And Ariel, thank you for your talk. And so great. Ariel, Diane, do you want to say anything else before I move on?
No, I just wanted to acknowledge also ODC Theater, who is partnering with us as well since I believe 2018 in this program. We actually did a performance at ODC this weekend, and our 3-year residency just finished. We're sad that it's over, but the performance was really beautiful. We did live stream for the first time, and it was really great. There's some of the performers are here today: Ben Guzman, Tanya London, Alex Benedict was helping us with the live stream, and who else is here? David Ruth.
I streamed, and Alex Law was a dancer. Yeah.
I was in the audience.
Hannah was in the audience.
Audience.
Anyways, yeah, I just wanted to acknowledge our partners. So thank you so much for doing this with us. This is one of my favorite events. We learn a lot from the artists and scientists and people doing all kinds of amazing things. And thank you, Ariel, for sharing your work with us today. It was amazing.
Great. We're going over a little bit on the time, so thanks, David, for being a little patient here. But we're going to move on to our next presentation. And we can do, what do we call it, Zoom clapping. So we're moving on with David. David Edwards explores new ways of improving human health and well-being through the air we breathe, with ramifications of how we eat and regenerate life on the planet. His scientific research, as well as his inventions, startups, and creative spaces in France and the USA, have led to the discovery of airway hygiene and the new consumer health platform, Fend. David's new Cambridge-based restaurant, Senses, reflects David's interest in food. He is the founder of Incredible Foods and follows 2 decades of exploration of public cultural innovation spaces, beginning with Les Laboratoires in Paris in 2007. The exploration is described in a series of nonfiction and fiction books in English and French, starting with art, science, creativity in the post-Google generation, and with the novelist J. Cantor Niche. So without further ado, David, take it away. And John, do you want to say anything here? Sorry, how'd you?
It's okay. just that David really does affect people. He really does change lives. I first met him like more than a decade ago, and he had a huge impact on my life and all my friends. I don't think he realizes the impact he has. He's a really too humble for his own good, but yeah, this is an amazing opportunity to have you here, David.
You're muted, David.
Haha.
There you are.
Hey, John, that's super thoughtful. And thank you, Ariel. That was really fantastic and incredibly relevant to the talk that I'm about to give. So thank you. I wish I were with you all. I am in on the other coast, and it's late here, so I'm going to rush into my talk. And could I, Alex, could you put my talk up? If you could just go to the next slide. So I So today was a big day for me and for us, which relates to FEN. So I'll talk quite a bit about it, but I'd like to spend half of the talk anyway talking about creating things that matter, and begin with this image. So we heard a lot about the ocean, one piece of the ocean from Ariel. Just talk a few seconds about the ocean. You know, I'm a creator, but probably many people here on the call think of themselves as creators and are creators. It's helpful to think about, I think, things in the natural world around us that clearly matter to us, and just the profundity of what that means. The ocean, in a way, is the simplest of all created things. It's the simple molecule H2O, covers 2/3 of the planet. And yet, as we've heard and as we know, it's also this incredibly complex, really conscious being, mega being, that supports life, has supported life from the beginning of life on the planet, that observes, adapts, evolves, and is still in literally every breath that anybody takes on the planet. Just incredible organism. Next slide, please. Next slide. Great, thank you. So we've been creating too, and unlike nature, tend to create things that are much shorter lived, and that's become obviously a major issue right now. And so this notion of creating things that matter is not that we all don't create pretty much all the time things that matter to ourselves or possibly those around us, but creating for others over a very long period of time is extremely difficult. And this image I'll come back to in just a minute. This was taken outside of Johannesburg in 2005. So yeah, next slide. So just a real quick review of my background. Applied math. So early on, I wrote a couple textbooks in the area of moving and deforming surfaces and transport and complex media, and thought that would be another life. I met Bob Langer at MIT and wrote a paper that came out in Science in 1997 related to inhaled insulin. It led to starting a company, which was super terrifying. Like Ariel going into an environment of scientists, me going into an environment of business people was a very terrifying thing. It was the late 90s. It led to a company that sold really quickly and had a big impact on my life. I came to teach at Harvard, and right around that time, the anthrax scare happened. And because of my work in a way, weaponizing insulin, I was brought to Washington, D.C. in a meeting that led ultimately to Homeland Security. And the question was, well, how do you prevent people from weaponizing anthrax? It led to this notion that I published in 2004 that while that may be difficult, what we could do was protect everybody by putting salt and water in the airways. And it seemed at the time that we could get rid of these little respiratory droplets that people talk a lot about now. But back then, even, as you probably remember, 2 years ago, nobody really knew whether these respiratory droplets had anything to do with infectious disease. But we began to explore that about 20 years ago. This led to a company called Pomatrix, and I'm just going to stop there and say, here I was, successful in many ways, and yet pretty unhappy with the work that I was doing. And that picture I took outside of Johannesburg came from work that I was doing in South Africa at the time, funded by the Gates Foundation. I was one of the first grand challengees, and we were developing an inhaled vaccine for tuberculosis. And I was really struck. There were a lot of things wrong with the work that we were doing, just in respect to the fact that there were no economies in Africa to really develop the work that we were doing. And then I was looking at all of this refuse outside of Johannesburg, and I can, in another talk, go into more detail on that. But just to say that I was struck by the fact that creating things to start a company or even meet a healthcare need there are processes obviously for doing that, but creating something that matters to many people, really independently of the free market and meeting kind of urgent needs. It's not really obvious. It wasn't obvious to me how to do that, and so I took, and I'm going to now spend about 10 minutes filling in those dots there and getting us up to this moment of FEN. and tell you a little bit about what I've done in the interim, trying to figure out how that works. And I should say before I go to the next slide that I had over all those years while I was doing math and some work on aerosols, I wrote fiction. I was really I've always been interested in writing, and I thought of that as a kind of a personal security in a way, and something that I enjoyed and I spent my mornings doing, but I never really thought of it as being critical to my scientific work. But in coming to Harvard, I realized that was wrong. So if you go to the next slide, please. So I left. I actually continued to teach at Harvard, but I moved to Paris and opened a cultural center called the Laboratoire next to the Louvre. This is a picture of it in 2007 when we opened it, and ran that for 10 years. And we did experiments with leading artists and designers at frontiers of science, and we invited the public into the experimental process. And so this was a kind of a setting that allowed us to, creators of all types, we sort of had to work together because we were dealing with problems or issues or opportunities that only artists and scientists coming together could deal with. And the public was sort of curious and was invited in. And so we learned a lot. Next slide, please. So I wrote a book that came out in 2008 called Art Science, and it was the fruit of those years and my understanding of the creative process as being this fusion of a process that's analytical and deductive and able to synthesize a complex world in the form of resolvable hypotheses, but also a process that's intuitive and inductive and comfortable with uncertainty and thriving in ambiguity. And those processes are absolutely interrelated and all in the same brain of the creative mind. And yet in our institutions, they tend to be separated. And ultimately, they become separated in our lives. And I think it leads to a much less creative and adaptive and resilient world. And so I was interested in how do you bring those together, and then how do you make it fun? So next slide, please. So I led the Laboratoire for many years, and from this, ultimately FEN came, but many other things came, and I ultimately brought it back to Cambridge and opened it in 2014 next to MIT. Next slide, please. So I'm going to talk about FEN, but I want to say that I wrote a book that came out a few years ago called Creating Things That Matter, and this is the my synthesis of these years and what I learned about these years. And before that, talking about FEN, I'd like to talk about my own understanding of the creative process and how it really relates to what Ariel just talked about. So if we could go to the next slide, please. So I think that creating is really as fundamental as this kid eating the apple. I think we're all innately creative, and otherwise we really wouldn't be here. All of us are facing with every day for sure, and often every minute, circumstances that we were not prepared to address, and so we're reacting to those situations in creative ways that have led to actually a transformed world. Next slide, please. So this will be a real quick overview here. I think that the creative process that I'll describe a little bit more is fundamentally driven by curiosity and play in a way, but play that's constructive and that's encouraged and that doesn't hurt us. And next slide, please. And yet creation, if you go back just to our survival, that's really risky actually. And it's taking us to frontiers where we could fall. And I think we're still having fun if we're doing it well, but we tend to be doing it increasingly with others. There's something about pioneering, creating that necessitates the buddy system, and you find this in all really pioneering creation. And again, listening to Ariel talk about what happens at 2 o'clock in the morning in the Antarctic as everybody's looking under the microscope their fingers, is getting to both this being at a frontier and having fun. Next slide, please. What creators who are creating over very long term and creating things that matter for many, many people have in common is that they're actually creating on a much shorter time scale. And they tend to be doing it in a process that is really three-phased. They're ideating, they're experimenting, and they're exhibiting. And ideally, they're doing it really quickly. And of course, scientists in their peer-reviewed publication or artists in their exhibitions, that's kind of a simple way of thinking about it. But it, actually, if you look at artists and scientists and how they are ideating and experimenting and exhibiting, it's actually happening on a much faster time scale. And one of the critical things that we do is we look for environments where there are people around us who care and who are engaged in each of these steps of the process. So I wanted to just make a few comments about this this process. So this, you may know who this is, Ferran Adrià, who led El Bulli outside of Barcelona for many years and closed the restaurant in 2011, was easily the most important restaurant on earth, at least at the time when he closed it. And as probably many of you know, he created over the years 1,848 dishes that were original. And so Ferran had, and if you visit him and see his creative environment, he had different sort of settings, labs, and so forth. And so quite a thoughtful and sort of scientifically organized creative process whereby he would ideate, and then the second they would experiment, and then exhibit. Now he had created a restaurant that actually was framed around this creative process, and where he had an audience that were sort of first adopters that came. And it's not that they were looking for the perfect, crème brûlée. What they were looking for was something new. And that was really sensational in kind of the literal sense of the word. So one thing that Ferran certainly did, and I think most, if not all, creators who ultimately create things that matter are conscious of, is that actually your audience that's engaging you at this level, not at the level of El Bulli, but really at the level of I'm having this dish that I've never had before and I'm not sure that I like it, are very conscious of is the importance of ennobling in a way that creative act. The interest of a spectator, if you will, or someone to engage in something that's never existed before is sort of needs to be honored. And creators tend to do this by creating a beautiful experience. And it may not be perfect and it may not be right, but it's an experience that becomes self-perpetuating. And so he was super successful at that, as many scientists are and artists are at their work. What happened with Ferran is that the restaurant then became so famous that people really became not tolerant of error. And not error in the sense that he did something he didn't intend, but something that was completely new, that nobody really knew how people would react. Anyway, I say all of that just to say that when it comes to, and next slide, please, and then I'll get to Fend. When it comes to creating, I think over the very long period of time, and again, Ariel's talk was so helpful in this regard, we're having fun. And again, we may be on the edge and maybe frozen and under the ice, if you will, but we're having fun. I want to talk about what that means and what it needs to mean. And so there's two sets of dimensions, if you will, or qualities on the left and on the right. And this is not the art and science of creating. This is not that at all. On the left, these are qualities that I have found are critical to successful creating. And they are not surprising, really. Passion, curiosity. And in my book, I kind of get into much more detail here, and there's a lot of nuance in what each of these words mean. But when it comes to being at a really new place that you've never ever been to, there are things that go on. And actually, people who've done this a lot love that, right? They're at a place where they can't use their cognition. They're calling on their intuition. They're innocent. All these things that contribute to you being really mindful and noticing and learning really, really rapidly. And we could talk more about, I just want to say that these qualities need to be protected. And so we create environments to protect them. But alone, they're really not sufficient to create the next Apple or the next Broadway show. There's a need for this culture of creating to coexist alongside another culture, which is more of a win the game culture that is more typically taught in the business schools at a Stanford or Harvard or wherever, and that are kind of more like qualities that are related to winning the war. And if you kind of look at those sets of qualities, they're quite opposite. And because of that, it's very hard to have a creating environment that creates things that matter, actually, because it's very hard for these things to coexist. And it's only rarely in certain homes or environments or companies or regions. And I think that Silicon Valley, in a certain context, and the hub in Boston and other countries, there are environments that manage to figure this out. But I'm going to stop there and just say that I think that creating things that matter, on the one hand, it's very natural. It's necessary for the survival of humanity, I think. But it has a fragility, and that's kind of how I think about it. So next slide, please. So I'm going to talk about Fend. We just launched Fend today, the ultimate Fend brand. And if you go to the next slide, please. To fill in the years, so my first company was an inhaled insulin company, and then I got involved with anthrax, and then I was frustrated in Africa and really thinking about how do we bring science and technology to people to really help improve people's lives. And I personally was frustrated by having regulated processes and billions of dollars between me and people who might benefit. And so I became interested in food. And so when I opened the laboratoire, I began to experiment with breathing food and putting food in the air. And why would you want to do that? Well, you wouldn't want food in your lungs, but you can kind of design it so that it falls out in your mouth and you eliminate the food form. And there's a lot of benefits to that. And so I began to work with my first top chef, Thierry Marx, in France, and we created something called the WIF. And that led to, we would exhibit these things in Paris, and there was a lot of interest, and in just in a purely cultural context, actually. And it led to something that I created with Marc Bretillot, a French designer, called Le Waf, where we now said, okay, well, what if you made like flavor in liquid form go in the air, and what would that mean? And that led to Philippe Starck, who's probably the greatest French designer, coming by and saying, well, and we created something called the WA. And then Massimo Bottura, was not at the time, but is now the #1 chef in the world, coming by for a weekend, and we made flavor clouds. And so a lot of play and learning. And my student, Rachel Field, who was in the class that John was in a few years later, we created something called the O-Phone and began to play with texting, sense, and things like that. And this led to this last image in 2018, where all of this had made me really passionate about food and about flavor and about olfaction. And we created this device that you're going to see again, where we could now create flavor clouds and really redesign food for human benefit. So next slide, please. So that sounds like a lot of experimentation and ideation and play and exhibition, and it's true. But it taught us a lot, and we had a lot of intellectual property and understood a lot about people, actually, and how people would do it right that they just don't do today. It's very hard to teach a new consumer right. The pandemic hit, and in the spring of 2020, we began to hear about again respiratory droplets, and I approached the FDA with my former advisor, Bob Langer, who was the head of the scientific advisory board for many years, and spoke to Janet Woodcock, who leads the drug division, about a hypothesis. And the idea was that it seemed to me that if we put salt in water, just through the nose, actually, and targeted the trachea, as I'll describe, we might be able to get rid of respiratory droplets and really make a difference in the pandemic. And the importance of that was that when you bring salt through the nose, and these are salts in the body, it can be regulated by the FDA as a cleanser, or cosmetic. It's a non-drug. And so it would allow us to really get right into humans and look at, and we had a lot of human data, but not for this particular anatomical location of deposition. And so we could see whether that was true or not. So next slide, please. So what I'd like to do, which is kind of a significant change here of focus, but I would like to now take a step back and say, here we are in the pandemic and all kind of worried about breathing. And just say, okay, what's going on here? And so I'm going to talk a little bit about respiratory droplets. And so I'm going to spend maybe 8 minutes here teaching a little bit about how our airways keep themselves clean. So obviously we've been breathing.
I'm sorry.
Yeah. So this here is showing the number of droplets that are coming out of people. These are 150 something people. These are the bars. And on the left side, number of droplets per liter of air. These are little droplets, smaller than you can see. Every one of you right now are breathing out droplets. Actually, you're breathing in way more particles in the air than you are droplets you're breathing out. But in the midst of those, you're generating these little droplets. Now you can see some people are making a lot, like 4,000, and so most people are making very, very few. And so why are some people making many more droplets than others, and why does it matter? We're going to talk about that, but I just want to point out that what we've learned, and this was in a PNAS part of an article that came out a few months ago, is that the older we get, the more BMI we accumulate, and lung infection are all reasons why we actually exhale a lot of droplets. There's other reasons that we've learned, but generally some people are breathing out many, many, many more particles than others, and actually they're breathing those into their lungs as well. So next slide, please. So the question then became, well, where are they coming from? And we were hypothesizing at the time, well, maybe they're probably coming from the trachea for reasons I'm going to describe, and that's really important. And let me just say that. Why is that important? So to be clear, when you breathe, air goes through your nose and mouth, through the windpipe, your trachea, and into your bronchi in your lungs. And what has to happen before it gets into your lungs is it gets wet, right? It has to get completely humidified, and it needs to get clean. So what happens in that little region is that all the particles in the air fall out, or not all, but a lot of them. And then all this water comes out of your mucus and into the air and humidifies the air. So it's this car wash kind of situation where you've got water thrown in the air, particles are being pulled out. And I was guessing that that's probably a place where things could go wrong. And that mucus could break up in these little droplets. And why was that important? Well, if that's happening, then if you're breathing in SARS-CoV-2, it lands typically in your nose and your upper airways before it gets deep. And it often never gets deep, so you never even know you've got COVID-19. It should get cleared. And that's true with influenza and all respiratory diseases. We're breathing in about 1 billion particles a day. And if you're in California right now with fire, it could be much more than that. And so generally your airways clean themselves really well. And I was guessing, well, maybe that breaks down. And if it does, and you get these droplets, that could carry these things deep in your lungs. All right, so we took this object that you saw in an earlier picture and said, okay, let's put these salts. And these are salts that are in your body, calcium chloride and sodium chloride. And I'll tell you why we need salts in a minute. And let's just have people breathe these droplets through their nose, size these particles just right so they land in your trachea. Don't go any further. And then see what happens. So next slide, please. So what we see here are just one of the articles. We've published 6 articles here in the last year and a half. You see the number of particles that people are breathing out in the gray. And then after they fend, it takes about 10 seconds. You see that they are breathing out very few particles. And this, we've now done several hundred from kids of 5 years of age to the elderly, 88, those infected with COVID-19, not infected, people in dirty environments, clean environments. And generally, this is a very soap-like effect that you see, and it lasts for about 6 hours. Now, next slide, please. Now, what's happening, just to kind of go really quickly to what we've learned, when you breathe, you have, no, right here in the center of your trachea, you have your larynx, and this is looking straight on. You may not know what you're looking at here, but there's a triangular, like on the open on the inhalation, that's your glottis. That's the opening of your larynx, where your larynx is most narrow. And inside there, like the white bands of that triangle are your vocal cords. And they have to be wet. And when they're wet, they kind of open when you breathe in and they close when you breathe out. And then of course, when you speak, they vibrate really fast, but they have to be wet. So we're gonna come back to that. Now, what happens is that, and you can maybe go to the next slide, please. What happens then is, so this is kind of showing here, again, you see the tube, guy on the left, you see the long tube, that's your windpipe, that's a trachea. You see the larynx is where that arrow is, right in the center. And then you get into the first branch, that's the main bronchi, and then you get the small airways. And so, as I said, all the cleaning and hydrating happens in that big tubes there. And that's where the droplets are being formed. And it turns out that when you breathe, over time, you dry out your airways, and as they dry out, the liquid, the surface, it turns out gets a lot of something we call surfactant and begins to break up. And so what we've learned here over the last couple of years is that when your larynx and your trachea dry out, and it happens a lot. It happens in cases of dehydration, older age, high BMI, diabetes. It happens in breathing of dry air. It happens in lung infection. You get a lot of these droplets, and they then become a real problem for carrying not only SARS-CoV-2, but influenza, and also allergens and carcinogens and other pathogens deep in the lungs. So next slide, please. So take a step back and say, well, David, if that's true, it must be true that hydrating like breathing humid air must help a lot your lower respiratory tract and limit disease, and that's true. And so there's been a real movement here for the last couple of years to get the WHO to recognize that actually breathing humid air is one of the most useful things you can do. It's helpful for COPD, asthma, influenza, COVID-19, and allergies. Now, it's a little bit more complicated than that. You have bad things in humid air, but generally breathing dry air is bad, breathing humid air is good. And we're learning now one of the fundamental reasons why has to do with, well, you're breaking the mucus up into little droplets. So next slide, please. So this led to, and I will finish here in about 8 minutes. So this led to NIH researcher Ad Bax calling me last November and said, David, I've been watching your work, and I'm wondering whether what you're describing is not actually how masks work, right? And so actually one of the things that surprised many of us is that masks, frankly, cotton masks or K95 or whatever that people are commonly wearing are have had quite an important impact on the pandemic and on, of course, flu season. And that's a little bit surprising because the droplets that are small enough to carry SARS-CoV-2 or influenza generally go around masks when you're breathing, and for many reasons. And so why are masks helping? And so, well, maybe they're humidifying the upper airway. So we did a study, next slide, please. We said, okay, let people put on a mask, they're in a dry room, and now we have the number of droplets we're breathing out is on the left, and time on the is on the bottom axis. You say, okay, I'm going to put on a mask, and for 2 hours, I'm wearing the mask, and I'm measuring your exhale aerosol. Your exhale aerosol is going down, down, down as you're wearing a mask. I take off the mask at 2 hours, and then over the next hour, it goes back. So just by wearing this mask, I'm humidifying my upper airways, and it gets rid of these droplets. So next slide, please. Now let's say, well, let's just say I take you into a humid room. You're in a dry room. You go and spend 20 minutes in the humid room. Same thing happens. Your droplets go down. Actually, it seems not counterintuitive, but you're hydrating your upper airways, and that actually makes them more stable. Bottom line, hydration. You need to be really well hydrated, and you need to hydrate your airways. So it looks very similar. So next slide, please. Well, what if you just put little droplets in your airways? Would that work? Like you put them right here where we're saying you need to put Fen. No. It actually doesn't work. And the reason is that water alone is not it. Your airways are lined not just with water, but with water and salt and other things. But the salt plays a really critical role. And when the salt is at low concentration,
actually the water gets pulled out of the lungs, out of the airway lining fluid into the cells, so it actually dehydrates you. And so you need water to have salt in it, and you kind of all sort of know that if you've been around the sea a lot. And so that's why you need salt. So next slide. Well, let's just say we put in droplets that are sized like they are with Fen, and it's just normal saline. That it kind of looks right now, if you look closely, it looks like you're wearing a mask. Next slide, let's say we go into hypertonic, so really high salt concentration, so it's a kind of more profound effect, but it's still about the same amount of time. And now let's say we have a calcium chloride. Next slide. And now suddenly, if you have a divalent cation, this is in the lungs, calcium chloride is in the lungs. But what we've learned is that calcium has a special interaction with the surface of the airway lining because it keeps it from breaking up for a long period of time. So next slide. I'm just going to finish. I don't know if you're all still there, but you've seen now all the data that I'm going to show you. Magnesium chloride, exact same effect. Doesn't really matter what's magnesium or calcium. There's a divalent cation effect on the surface of airway lining. So next slide, please. This all brings me back to this. So the ocean, all the salts in the ocean are in your lungs. And the reason is that salt from the ocean gets put in the air by spray. It gets carried up into the stratosphere. It goes around the earth. And so salt is in the air wherever you are, and more if you're near the sea. And so you're breathing in calcium, magnesium, sodium, potassium chloride, and they are actually, the body has made use of it. So we have this equilibrium with the environment. It's really critical. And it must mean that, well, if I'm like right near the sea, it's probably better for my lower lungs than if I'm not. And that turns out to be true. So in our last slide, we did a study with my colleague at Harvard School of Public Health, Francesca Dominici, who is a biostatistician. She published that article on pollution and COVID-19 in the United States, showing that there's a real effect of pollution on COVID-19. And so we did a similar analysis of the pandemic, from the beginning of the pandemic up to about March, when we had about 15% of the country vaccinated, and said, well, what's the probability of getting COVID-19 or dying if you live somewhere in the United States, and particularly if you live on the coast? And what we found is that particularly if you're in a coastal county, on a coast where the wind is blowing off the sea, the Pacific coast or the Texas Gulf panhandle, your probability of getting COVID-19 or dying is about 25 or 30% less than anywhere else. Having accounted for age and obesity and voting patterns and economic circumstances, about 10 different confounding factors. So next slide, please. I am going to about end and talk about the product here, but I just want to say that what has made me so passionate about this is that we've been in India for the last year, and a really heroic medical doctor who's been leading these clinical trials at Bangalore Baptist Hospital, pictured here, has been doing studies and looking at what we just talked about, cleaning the airways, and not really looking at any kind of treatment or prophylaxis. The pandemic took a really bad turn in the spring. And it led to, everybody being rehospitalized, including her. 4 of her scientists in her PCR lab died. It was just a horrific situation. And they began they got approval to do a phase 2 study, basically. And so they, COVID-19 patients coming to the hospital were, if they were not on oxygen, they were randomized into a control group that just took a nasal saline for 3 days, 3 times a day, or they fended 3 times a day for 3 days. And the results are just right now being submitted. We've done a big study in a few continents here over the last 9 months, and there's a Fast Company article came out today, kind of talks a little, refers a little bit to this, but it's actually not been peer reviewed, so we're just submitting it. But we found that there's a very significant treatment effect and some really interesting effects on oxygen saturation and so forth. So next slide, please. So I believe that we are at a point where we have discovered the next hygiene. If hands are cleaning hands are a means of limiting the risk of gastrointestinal infection. Cleaning the airways are similarly a risk of lowering the risk of lung infection. And it really is across the board from something like COPD to COVID-19. Next slide, please. So I wanted, just because you may want to see, does this actually work? I'm going to just show you here 1 minute video, and then I'll have like 3 slides, I think, left. So this is, I'm going to show you some, yeah, you can start it. Go ahead. Yeah. So this is Mark, and we're going to watch him measure, we're going to measure his, okay, here's the particle counter. He's breathing into this thing. You can see the total number of particles, the bottom number. That's all the particles above 300 nanometers. He's breathing out about 300 particles per liter. Now he fends, 15 minutes pass. This is our office. He comes back, and now he breathes, and now he's down to about 70, 80, or 100. That's still not that low. We're gonna wait another 15 minutes. Now he's gonna come back, and now he's down to about 10 or 15. And now this goes on, and it lasts for about 6 hours. So there's this really simple, it's like a few milligrams. It took him about, he does it twice, and I'll do it myself just to show you, but it really cleans out your airways. So yeah, next slide, great. You can go, you can flip, actually. Yeah, there you go. So we brought a product out a year ago, and this was a hack of what we'd done for flavor. And we've learned, so this is a step out of the laboratoire where we're kind of just, amazing consumers have taught us a lot and could tell you a lot. A lot of people have fended, but it also really led us to understand, next slide, please, that we needed to, for a global hygiene, we really needed to bring this to a different level. And so began to work with Robert Brunner, who was the lead designer at Apple many years ago, and now is a co-founder of Ammunition in San Francisco, and he most recently designer of Beats by Dr. Dre. And so he and his team worked closely with us to bring Fen to a point where we could get it to many more people. So next slide, please. So today we announced that the sale of the new Fend, and I have it with me, and I can show you how it works. But it's very simple. It's sterile, so there's no preservatives, only salt and water. It's stable for as long as the device is not crushed, basically. Next slide, please. The product, and I will get to the end here and then just demonstrate to you how it works here. But we have a not-for-profit that we've set up, or we've been helpful in having it get set up, called Next Breath, led by Lori Carnath, and aiming to get airway hygiene to everybody who needs it. You may not, or you may know that in the developing world, respiratory disease is #1 killer right now. 1 billion out of 1.6 billion kids today are not in school, or at largely because they're in multidimensional poverty, partly because of COVID-19 pandemic, and most of them are breathing really, really dirty air. And so helping kids breathe dirty air or breathe clean air is a real priority for me and for us. So next slide, please. So you can check us out here, and I do want to just sort of demonstrate you. Next slide, please. So there's also like a line you can Harry for. Yeah, so we're in. Okay, could you go to the next slide, or maybe just get rid of the slide so I can just see everybody, Alex? Thank you. So I've got here. Let's get you on. So I have here. This is Fend. And so Fend, you kind of squeeze it, and it makes this cloud. So the way it works is you put it in front of your nose, and I'll show you. So you do a deep nasal breath. You want these droplets to go nose, and then right here, trachea. And the amount of salt that you put in is equivalent to a day and a night of breathing sea air. So it's about 15,000 breaths of sea air. It gives you the amount of salt that you're getting in a single administration of Fen. So yeah, that's my talk. So thank you so much for having me, and I'd love to answer any questions. Thank you.
Thank you, David. That was incredible. I'm going to guide everyone back into gallery view. We're going over 15 minutes. Thanks for staying with us. Can't combine or, keep it something to one time. So thank you for staying with us, and feel free to open up to questions or unmute yourself.
David,
Yeah.
I have so much admiration for what you have done. It's so the one of the most difficult things is see through the thing that so we take all for granted, like the mask we all taking for granted. Oh yeah, the mask block the filters of the air, and stop thinking what's actually happening when you have the mask on. So I think this is a perfect example of what you talk about, art and the science, and the artistic mind, and in the science, and that leads you into this discovery as a really
Yeah, no, thank you. Thoughtful. Thank you so much. I mean, I think I didn't have much time here, and we kind of tried to cover a lot, but I think that the the spirit of play, the time to be curious, and then I think there's something else that I've learned way actually over the last 25 years. I think that in the process, and you saw it in Ariel's talk, I think you see it in her work, in the process of playing and following your curiosity, you're part of a much larger narrative that maybe you don't see until you've lived long enough and had a chance to kind of go into different circumstances. Oh my God, I've been part of this story.
Exactly.
That's totally what we've seen here. And it's the other thing I guess I would say is that the pandemic, it's one of these moments where people are changing how they live. And it's rare that happens actually. And so it's something that all of us who care about life on the planet, we need to seize this moment, right?
Yeah. You also talk about the playful mind and the goal mind. There's often there's a conflict, and like what's taught in the business schools is about the goal, achieving your goal, be successful, succeed. Well, like if we have this kind of mindset, I can guarantee you won't have that discovery that okay, actually how we protect ourselves through the mask is not actually just through the mask. And we actually have an experiment that we're doing that we organize labs every week, and well, there's one room in the lab, one room only is the lab. You're not supposed to achieve anything.
Yeah, and I mean I think it's pretty simple. It's pretty intuitive. It's also pretty aggravatingly difficult to put your finger on. I think all of us know the importance of discipline and focus and only doing what you know how to do, and all of that is so true until it's not, right? And so I think that, and that's where I think when it comes to codifying all of this, I don't even know that it can be codified. I mean, I have written books and tried to put my arms around it, but I think that what if you have, and all of you do, I know, but spent lots of time in really successful creative environments where you go from the playground to the the outcome, if you will, that is being consumed. There's people kind of get when the education's over, and it's like, you know what, it's been 2 years, you've been in my class, but you've graduated. That's how it's done. Go. Then it's kind of, you sort of just know it, right? And so you couldn't really kind of write that down. So yeah, I'm not going to talk more. I'm happy to answer any other questions.
Yeah, hi. I'm curious about the relation to, like, because you have kind of this, with the device for measuring, you have this metric, which nowadays people love metrics, right? And I'm wondering whether having the metric would provide a way for a civic policy changes at a local level, like whether the city would be able to say, okay, if people are willing to install this device and people can test themselves, can we say that they're safe even though blah, blah, blah?
Yeah, totally. Yeah, I mean, so I've spent all this time talking about these respiratory droplets, and you're, Kurt, putting your finger on obvious fact here that actually these respiratory droplets are a really, really interesting diagnostic. And we're honestly, we've got now several hundred, we've tested several hundred people, but in really certain, actually, we have a lot to learn here. But I think that, yes, I think that and to be honest, watching public policy here over the last couple of years has been really, really hard. And I think that I get how difficult this has been for journalists, how difficult it's been for policymakers, and frankly, really difficult for scientists, because scientists are learning, right? And so it's like, this is sort of a really fun time to be a scientist and involved in all this, but it's also terrifying because you're wanting to call your colleague and say, well, what do you think? I don't know. Maybe you think, kind of spend the night thinking about it. And then everybody's just saying, tell me. It's like, what's right? Right. And so there's this real challenge. So all of which is to say, I am hopeful. I'm generally hopeful, but I'm hopeful that the discovery here over these last couple of years are really making human society and civilization more resilient than less resilient. And I do think that the quantification is helpful. Yeah, for sure.
Thank you, David. And I just want to say, I want to learn more about it also after this call, because as someone that has suffered with asthma all her life, I found out, little tricks that made sense. When I went to school in Santa Cruz, I had no problems, moved into the city. I couldn't sleep. I had breathing problems. And then realizing, during the pandemic, wearing a mask actually helped me with my allergies. So everything made real sense when you said it. And it's just, I really appreciate sort of this transparency that you have with all the research that you've done thus far, and for getting into the details with us, because
we need to get into the details. I mean, it's kind of, that's one of Frank, well, whatever. There's many things to talk about, but just to say, so we've had now 10,000 consumers, and so people using a lot. Actually, you might say, well, who's using it? Very typically, care providers, so mothers with kids, employers with employees, or teachers, students, and so that's a typical profile. But very commonly families, and very commonly kids. And a really common feedback is that, I got it because I was afraid, and I'm using it because I don't have to take my allergy meds anymore. So there's a real allergies, exercise-induced asthma. The long-term benefits for asthma and COPD are really long-term. It's really hydrating your upper airways is helping your airways clean the air better. And so basically the probability of irritants getting into your central and lower airways goes down. And so that's kind of what you're feeling with the mask.
Yeah, because in steroids, the things that they prescribe you to, it's just addressing the symptom, not really helping you actually breathe better. So it's just really exciting.
Thank you.
I got a question, David. Doesn't it strike you as uncanny, this bit of math you studied so long ago, the very beginning, studying surfaces and this curious little niche, and it just keeps threading through your life.
It is. So John was in my class 10 or 12 years ago, whatever it was, and we lost touch, and it took about 10 minutes of listening to John and looking at that smile, and I totally remember you, and it seems like 20 years, maybe you would have asked me this question 12 years ago. I think that's true. I think it's also true. I've often taught this class where I have students come in and we talk about creating things. And my recommendation to students is really my own recommendation in kind of response to your comment. I think what we all need to do is really pay attention to the life around us, and just pay attention and be mindful of what you know and what's happening around you, because it's only happening around you, right? You're like there's only you having those experiences. And so here's this guy who studied applied math and surfaces and all of that, and kind of in my space. And so it's true that that's kind of threaded through everything I do, but so have I. And so it's been kind of, and I think that's whether you're a novelist writing or a scientist doing science. I think that if you live long enough, I guess that's my thought to you. And I have lived a long time. It does thread, and it's really, really moving, actually.
Thank you so much. I think it's
okay. Thank you all.
To close forum.
Yeah, thank you for showing up, everyone. I just want to say, last thing is that this happens again every month at the last Wednesday of the month. I will put a recording of this up on the Kinetech Arts website. I will share it with the artists as well in a couple of days once we polish it up. And yeah, I just want you guys to spread the word of this event. Share what this is all about, intersecting art and science, because I think it's a really important space and conversation to be having with you all. So thank you, David. Thank you, Ariel. Thank you for staying late. This was amazing. You can unmute yourselves.
Thank you.
Thank you. Thanks so much.
Thank you very much. Thank you.
Thank you.
Very inspiring.
Beautiful.